Right, let's go through and see if we can document all the moving parts of AFC, PSM, CX10,000, vCenter, and ESX. So this is the combination that we would have in a production deployment. Let's have a look and see if we can draw all the pieces. So AFC, if you're using AFC, it is deployed as a single standalone virtual machine or as a cluster, depending on your deployment requirements. Let's make this a bit smaller. Right, so we have AFC, then we have PSM. So PSM is also deployed as a single virtual machine if you're using 10 or fewer CX10,000s, or it is deployed as a cluster for larger deployments. So AFC has integration with PSM. Now if we have vCenter or vCenter servers, that is also deployed inside the network. So vCenter is configured here, and vCenter is also linked to AFC. So let's just jump into AFC and have a look at the integrations. So what I'll do is I'll actually delete both of these and we'll re-add them. Refresh that one. And go to PSM. I'm just going to delete my PSM server as well. Alright, cool. And that'll disappear from here. And look at vSphere, that will have disappeared too. So the first thing we want to do is we want to add vCenter. So we're going to add, okay. Now you should really ideally use a valid resolvable host name here and not rely on a static IP address. Likewise, you probably shouldn't use the administrator account for a production deployment. Tick all of these options here, including the automated endpoint provisioning. Change any VLANs here to include the ones you want to be able to modify, and certainly exclude any VLANs that AFC should not be trying to provision inside your network. Enable discovery protocols here because LLDP is required for the topology visualization, and apply that. It should go to a connected state. If it isn't, stop and investigate why. Then we come down to Pensando, we add in our PSM server or servers. And again, next, we need to select the fabric we have. I've only got one fabric called DC1. If you had more, select these. Leave the auto-enabled VLAN placement option ticked. Select the vCenter server we just added here. Right, and this will move to a healthy state. Now we can validate this. Actually, we haven't linked it inside PSM yet. So make sure this is healthy. Make sure that the vCenter configuration is also connected, and then you're good to go. So what we've done is we've linked this setting here. We did vCenter first. We also told PSM to also have a connection to vCenter as well. That was one of the options we ticked. So now we have all three of these really talking together. It's important to note that really the configuration is works in both directions. I can make configuration changes inside PSM, and these will appear inside AFC. I can make changes inside vCenter, and likewise these will be absorbed into AFC. Right, so now we have the other pieces of the puzzle of our virtualization strategy here. So let's have a look at our ESX hosts. So I'm going to draw it further down. I've got a single ESX server. And that is being managed by let's just draw a straight and solid line. Be managed by vCenter. I have a CX10,000 switch or switches. That is being managed by, well, it's actually two parts to it really. So AFC is managing the CX10,000 and so is PSM. So AFC is responsible for configuring, or directly configuring layer 2, layer 4, layer 2 and layer 3 configurations. That is layer 2 here. And this is responsible for configuring all your layer 4 configurations. So this goes to the DPU. This goes to the Trident T3 and the CX operating system. But there is an additional step you can do. So you can have AFC provision everything, and I'll push it up through here and through here as well. So you can make configuration changes here, or you can make configuration changes here. Right. Now we will have a connection between our CX10,000 and our ESX host. Now we leverage LLDP for neighbor discovery. So if we don't support LLDP down here, we have a problem. If we have a chassis-based server here that has some integrated switch inside here that may not support LLDP, then we could have issues here as well. Now obviously we can have multiple links in here, and we probably would. And we could also have connections across to a second CX10K as well. Now, obviously, we would have multiple of these devices too, so there could be more here. Right. Cool. So this is our management side here in green, and the connection or the communication flows. This is our switch, our virtualization platform, which could also just be bare metal as well, and our physical links between the two. Right, so if I jump back into AFC, you'll see I have right. Let's see if we can make this a bit smaller. Right. I have my CX10,000 switch here. This grey box here is the VMware hypervisor. You can see the VMware logo here. I can click on this, gives me the details of the hypervisor, number of VMs I have created here. I can create micro-segmentation here. And creating micro-segmentation, that means it's going to create a virtual distributed switch, or a vSphere distributed switch, sorry, on the hypervisor or on vCenter. So the two things to consider is create micro-segmentation creates the virtual switch, and these are the virtual switches, and if I update pVLANs, that creates a port group. So inside vSphere you have vNICs, so that's the physical, PNICs, that's the physical NIC that attaches to the network. You have virtual switches, and you have port groups here, and then you have the VMs or workloads attached here. Right, and we're using LLDP to discover things, so here's my switch. So make sure we can click on the CX10K switch. It could be another type of CX switch as well. We can see that it's healthy, it's connected in here. I can click on the physical link, so this is hold on, let's go to that, yeah, 1133. Link is up, it's 10 gig. Okay, it's MTU, cool. And this one has got VLANs all, I suspect, configured on the physical configuration. Let's check that. This is 134. Okay. Interesting. Let's just refresh this screen. Right. Oh, that's better. I think after I added in the vCenter integration, I had to refresh things because it was still learning the different trunks, sorry, VLANs configured on the trunk. You'll notice that all of VLANs configured on the trunk here. If I look at the interface, right, so these are the VLANs that are allowed on the trunk. You could also have VLAN all here as well. If you don't, then AFC will automatically provision the VLANs for you. Cool. There is two types of personas as well for interfaces. So I'm just looking at this. The default persona is access. If you can either have that configured as access or leave it alone, and it will default to access. Access interfaces are always the ones that are facing towards the workloads, and uplink interfaces are the ones that are facing into the rest of the core of the network. Right, so let's have a look at some of these moving parts if I start making some changes. So here is my lab virtual switch. We can look inside vSphere here and you'll see I also have the lab virtual switch. So these are constructs that are created inside the VMware vCenter. A VDS requires the use of an Enterprise Plus license. Likewise, the use of LLDP also requires an Enterprise Plus license as well. We have to have vCenter to make this work. To use a VDS, you need vCenter. To use VDSs and LLDP, you need Enterprise Plus. So there's a couple of things we need to be aware of there as well. So let's have a look. I've got these here. If I create a new microsegmentation, a new PVLAN, sorry, I can do it from here. I'll show you a couple of other ways of doing this as well, but let's just do a simple one here. So I'm going to give this a name. Let's just call it testing. All right. Now the port group name, this is the prefix that goes in front of the PVLANs. I need to give it a primary VLAN. The primary VLAN is the base VLAN or the promiscuous VLAN through which all traffic will be switched. So we'll put in a number here. Let's choose something 1200, and then I'm going to make 1201. I can add this. I could also do another one if I want to. I can do as many as I want here, and just keep adding these here. So this will create 4 port groups: a promiscuous port group, an isolated port group, for both these VLANs and this VLAN. Right, so it's how these, you should always see this as being green. If it's not green, then something has happened. Jump back in here, you'll see that that refreshed. Now I called it testing. So I've got 1200, 1201, 1300, 1301. So 1200 is promiscuous. Promiscuous is the primary VLAN through which all traffic is switched. If I have a workload attached to, obviously attached to VLAN 1200, then all the traffic will be switched through VLAN 1200. If I have a workload attached to VLAN 1201, this is isolated. All traffic will be passed upstream to the promiscuous VLAN and switched through here. Nothing is allowed to communicate on an isolated VLAN. They have to come up through the device that is the promiscuous pathway for VLAN 1200. So we can do it this way. Now, if I come back here and look at AFC, now AFC knows that this virtual switch here, this VDS, is attached to these two interfaces. And it knows that it is connected to ports 1134 and 33. So this will be reflected inside the configuration. So if I look back in my switch, first thing we'll do is show VLANs. Maybe we'll make this window a little bit bigger. Right, show VLANs. I got way too many VLANs on here, 1200, 1201, and 1331. So it's actually gone away and provisioned these on these interfaces for me. So 33, 35. So AFC will orchestrate the creation of the port groups inside vSphere. It'll determine which interfaces upstream are connected to that VDS, which could be on multiple CX10Ks, and provision the trunks appropriately as well. So I can look at show VLAN 1200, it's here. I can look at show primary VLAN, private VLAN, and you see that we have these configured. Right. So I can make VLANs all day, or private VLANs to my heart's content inside AFC. I can also create them inside here. So some customers may want to create their own PVLANs using the vCenter admin console. So I can come in here and go VLAN 1400 if I want. And then add another 1401, make sure this is isolated, not community. Right, this just allows me to now make a port group using that. So new port group, testing, 1400, right. I'm going to make it a private VLAN. I'm going to configure it on the pair I just created. So I have the choice now in the console of using promiscuous or isolated. I'm going to choose isolated. Right, and now it's made 1400. There it is here. Right. So, and if I come into AFC, and maybe we need to zoom back in. It'll appear here as well. Let's just refresh this here. Here it is here, and you'll see it's isolated. So any VMs attached to this isolated network here have to come up to here. This VDS knows that they're isolated. It won't allow two VMs to talk to each other. It'll have to find another way to get to a non-isolated device on the promiscuous or primary network, which is up here. It's not here. Okay, so let's go back to a little diagram and just have a look at this here. Okay, so I provisioned VLANs, a PVLAN. So I did a PVLAN. Let's say it was 1300 and 1301. I also did one of 1200, 1201. I configure those directly inside AFC. AFC then went and pushed that down to vCenter. It knew it was attached to the lab VDS, so it made port groups, 2 times port group, right? It also provisioned the PVLAN mapping. Right, so it did that for me. I also went directly into vCenter and did the same thing as well. So I configured a PVLAN mapping here for 1400 and 1401. Then I made a port group called testing as well. And that gets pushed back this way, right? So bidirectional here or here. So AFC has visibility of all this. It then comes across here, down to the CX10K, programs the switch to have these VLANs, so was it 1300, 1200, 1400, and the corresponding PVLANs. Cool, here, it's already provisioned these here. It knows that lab virtual switch is attached to these 2 ports. It follows that up here and ensures that this trunk is successfully configured as well. So that's how those moving parts work. Let's attach a virtual machine to this as well. So we've provisioned our layer 2 construct basically. So I'm going to do all my work now on, let's say, VLAN 1200. So I'm going to come into routing and VRF. I'm going to do all my work inside the default VRF. I'm going to configure an IP interface. So if I come back in here and do show interface VLAN 1200, VLAN 1200 will become the focal point for routing and for switching. So any devices on the same VLAN that are connected to an isolated PVLAN instance, in this case VLAN 1201, will be switched through VLAN 1200, which is the primary VLAN of that pair. I don't have an IP interface on here, so let's make one. So I'm inside the default VRF. You could use a different VRF, but we'll use default SVI VLAN 1200. I'm going to put it onto my single CX10K switch. There could be other options here if you had a bigger network. I'm going to choose 192.168.12. Let's say 120. Let's do that. And I'm going to give it a range of addresses that can be selected, assigned to different switches. So I've only got one switch, so I'm going to put here 20.2. If I had VSX pair, or I was using EVPN Anycast gateway, I would have a range of addresses, which I'll then just use a hyphen. So I could just do this 120. Let's say 9. But it'll choose the lowest address first. My gateway address will be 192.168.120.1, and we need to configure an active shared MAC address for the gateway. So I normally choose 0020, I think, or 02, because that's a private MAC address. 0000. Let's choose this 01. Just make something up. Enable local proxy ARP. This is important for microsegmentation only, really. It forces all the traffic to essentially switch through the CX10K or any other switch. This is a pretty standard construct for any switch to support. So when one VM does an ARP request for the other VM's IP address, the CX10K will respond on behalf of that device. So it is basically representing the MAC address of the destination. Give it a name, so VLAN 1200. Oop. My demo. Oop, can't type. Right, next. Cool. Created VLAN 1200. So, cool. Okay, so that's now there. You'll see that it's actually given an IP address of 192.168.120.2, so it's chosen the first available address from that range of addresses. I don't have to configure this, but if I had more than one CX10K acting as a gateway, then I would have this type of construct. It's configured a MAC address. I've configured here. This MAC address will be present on multiple devices that act as the gateway for this subnet. And the default gateway address of 192.168.120.1. And I've configured local proxy ARP. So I've configured layer 2, I've configured layer 3. So again, I went into AFC and I said I want to configure interface VLAN 1, 2, and I've given it an IP address, MAC address, local proxy ARP. It's now gone up to AFC. AFC has gone directly over here and it's programmed the configuration into the switch, written that into the configuration file, and saved the configuration for me. Right, that's done. So we've configured layer 2. Oh, I keep doing that. Layer 2, we've configured layer 3. And now we are ready to attach some workloads to our isolated VLAN. So let's do that. I've got two VMs over here, so B1 and B2. Let's attach these to my, what do we call it? Testing 1200. We don't want to attach it to 1200. we want to attach it to the isolated pair of this two. And we'll do the same for B2. So remember, show private VLAN. We want to attach it to the isolated member 1201. That way traffic, anything on 1201 will be isolated. They have to come up to VLAN 1200 to allow communication to occur. Right, so let's just get onto these two virtual machines here. Right, get onto the web console for this one. And the web console for this one. Right, I'm going to change the IP addresses on here. So B1, 192.168.120.11. Oh, I put the wrong one. Damn. Need to put it onto. Right, here it is. B2. Okay, so I've now connected that to that network. So let's go back to B1. First thing I should be able to do is ping the gateway. I can. So I can ping the gateway. So traffic is going from, I've got two VMs. So my VM is here and the other VM is here. And they're both connected to the same port group, which was called testing 1201, which is connected to the lab VDS. So right now I've sent a ping to 120.1. Now if we look at that interface again, it has a 120.1 has got a MAC address of this. Okay, 120.1 has got a MAC address of 0002. Okay, great. Now let's ping B2. So B2 has got a MAC address of 005056B3734E. Right. Let's ping 12. The response. Good. You see the first ping packet is slow because the ARP request had to kick in first. Let's look it out. And 120.12, sorry, has got the same MAC address as the default gateway. That's because local proxy ARP here is responding on its behalf. So if we look at the MAC address table for VLAN 1200, it actually knows how to get to each of the VMs, but it is masquerading on behalf of these two devices here. Right, so far so good. So we are currently sending traffic through the CX10,000 to get from one VM to another. So back in my diagram here, to go from this VM to this VM, I'm now coming up here. The CX10K is responding to my ARP request, so I send traffic to him. It knows how to get to the destination MAC address, so traffic is coming up here and coming down here. And likewise, the return path is here because B2 knows that to get to 120.2, I also have to send it back, not 120.11, I also have to send it back to this MAC address, which is the CX10K. So it is acting as a proxy, a man in the middle between both of these two devices sitting on the primary VLAN of 1200. Right, cool, so far so good. Now the default behavior for the CX10K when I have performed, when I've configured layer 2, I've configured my layer 2 configuration, right? So layer 2 has been done, layer 3 has been done, layer 2 has been validated, layer 3 has been validated, right? This works, this works. So we are acting right now as a traditional stateless switch inside the CX10K. We are not doing any security services. We're not doing what we call redirection. So right now I'm residing directly inside the Broadcom ASIC. Right. So all traffic always passes through the Trident 3 ASIC that sits inside the box. Right. So T3 Trident. Right. Cool. So the default behavior is to do that. But now I want to get traffic up to the Pensando DPU. So the DPU, there's two DPUs that sit inside the box. They're both attached to the T3 ASIC in here. See if I can color this in a bit more. Right, and I want to get traffic to come through here. So this is called redirection. So if I log into my switch and do a show DSM redirect, you'll see I have, let's have a look at DSM. I have two DPUs, which are known as Distributed Services Modules, DSMs. I have redirection here. Now, we do not see VLAN 1200 here because the default behavior when we configure microsegmentation instances and PVLAN constructs is to not redirect that traffic. So now we want to get traffic to come up into our DPU to be processed and be sent back. So to do that, we simply come back into AFC. This can also be done inside PSM. Up until this point, everything we've done has to be done inside AFC or through the CLI of the Aruba switch. But now we're getting into the area where we're starting to do configuration on the Pensando DPU. So we come to networks inside, so this is configuration, routing, VRF, select the VRF we're interested in, come to networks, and you'll see that these list of VLANs here look the same as these VLANs here because that's what they are. Add 1200, right? We're going to redirect VLAN 1200. Remember, we do all our operations from the primary or promiscuous VLAN. Right, that is now here, and that is now here. So you'll notice that it actually picked up both 1200 and 1201. We only have to configure the primary VLAN, not the secondary or isolated VLAN. Right, so far so good. So now, in our diagram, traffic is now coming up through here. This is now being drawn in red, here, up here, and back down again. So the DPU is it's a bump in the wire. Right, it is transparent. It doesn't get involved in any switching, routing, or forwarding decisions. It is essentially just pack it in, pack it out. When we configure redirection, as we just did, we have not configured a security policy. We have not configured any rules. So the default behavior for redirection is to permit all and log. So right now we are redirecting, we're allowing all traffic, we're not changing any behavior on how things work, we're not restricting traffic flows, we are simply bridging the traffic through and we are forwarding it to its destination. We do have a good side effect of actually having log capture at this point. So our ping between these two devices should still function. 12, which it does. Now the latency we had before was 0.25, 0.3 milliseconds. It's pretty much the same. Worst case scenario, we're looking at about 1 microsecond to 3 microseconds of additional latency. So a very small number of additional latency is added. Right, now, just from a diagnostics perspective, we don't have to go and show customers this, but if we want to have just to validate things are happening or things are not happening, if something is broken, so we can type diagnostics, we can jump into the DSM console. We need to have a look and see which DSM we're going to, which is 1/1, console 1/1. And the command is pdsctl and then show flow. And we should have two flows here. So we've got source, destination, ICMP, A for allow. Right, so use this to validate that we have redirection correctly functioning. If we see redirection configured here, we will be redirecting. Traffic coming through here will establish an entry in the flow table. Without a policy defined, we still build session entries, but it will always be an A for allow. Right, now we need to attach a policy to this. Let's have a look in PSM as well and just go over what we did. So I did network redirection here. I can also come into PSM, networks, and you'll see that VLAN 1200 is here as well. Let's just redirect VLAN 1300 while I'm here, because that was the other one we made, VLAN 1300. I get pretty much the same options here. I can also apply security policies, which we're going to get to. This is going to be the default VRF. This is VLAN 14, sorry, what was 1300? We do this, right? And if we create this network, and come back in here, we'll see that we have, we don't have VLAN 1300 yet. Why is that not there? Probably because I haven't configured any port groups that use that VRF yet. So, okay. It will say here it's pending. Oh, it's complete. Oh no, it is there. Yeah. Okay, this is a good point actually. So it will choose which DSM to send it to, but you can actually do this, override this at a VRF level and ensure that all traffic from inside one VRF always resides on one of the modules, which I haven't got configured. Okay, you can delete that from here as well. Right, so what I did there was actually went straight to PSM into here, and that went across and did my work for me here as well. So redirection can be configured from layer 2 and layer 3 has to be configured from AFC or directly on the switch. The redirection can be configured inside AFC or in PSM, and then once we start getting into services, that can be configured inside AFC or PSM as well. Right, let's get some policies in place here. So now I'm going to leave my ping running here. I'm going to come into AFC, and we'll do this inside AFC, and then we'll start again and show you how you can do this inside PSM. You can do this in AFC or PSM. You could potentially do it in both for production. I would pick one or the other. You could draw the line at configuring networking inside AFC, and you could do security inside PSM. It's up to you how you want to do this. PSM is always mandatory. AFC is optional, so you have to think about the outcomes from this as well. Come down to policy. We're going to create a new policy. Policies are a collection of rules. Let's make a new one here called let's say it's our production database network, right? It's always going to be type distributed firewall when we are dealing with a CX10K. It could also be ACLs as well, which should be configured on stateless devices. I'm going to leave this empty here. We could actually start adding rules at this point. Under enforcers, we're going to select the fabric that I've created. We're going to say it's going to a leaf switch, which is what I have. I'm going to leave policy distribution targets alone. We use these if we have larger deployments where we want to selectively configure where the policies are sent. We're always going to make this an egress for workload traffic coming into the data center fabric. As much as that sounds backwards, we think about egress as being the direction of the traffic away from the workload. It goes into my default VRF, and we're going to attach it to VLAN 1200. I could attach this to multiple networks. I could leave this empty and just attach it just to the default VRF. So I can do this. I could come through and do the process again and attach it to other networks as well. So it's now telling me that the default VRF in Data Center 1 Fabric, VLAN 1200, or the network called VLAN 1200, yep, in this direction, which is traffic coming into the fabric, is going to have this new policy with no rules. Right, so now I've done this. As soon as I do that, this is pushed directly into PSM. So AFC has now gone to PSM and said, here's a new policy. Please attach it to network 1200, so this up here, the DPU is now waiting for traffic on VLAN 1200 with this new policy. We have already configured redirection for VLAN 1200, so it'll all be in place, ready to go. Now we come back to look at our server here, and our ping has stopped working. This is because when we create a new firewall policy and attach it to a network, there is always an implicit deny at the end of this rule group, right? If I come here and select rules, you'll see there is no rules. There is an implicit deny taking place. I can come back here and go and look at my diagnostics again. And we'll see we now have a D for deny. So this traffic is now being blocked. We've essentially stopped all traffic on VLAN 1200. This is microsegmentation in effect. I have two VMs in the same hypervisor trying to communicate to each other using ICMP, and it is not working. Because I have no rules, I'm now hitting the implicit deny. So let's fix that. We'll come into back to policies. Hold on. Policies here. Why is this not doing? Okay, we'll do it a different way. Something's not happening there. Going to make a rule called ICMP. It is layer 3. Yep, it is an allow action. I'm going to leave source endpoint, destination endpoints empty. The default is any. Applications are going to select ICMP. Now, what do I call this? ICMP. I've got lots of them called ICMP. Okay, it's probably this last one. Why is it not letting me attach that to a policy? Where's my policy gone? Oh, there it is. Okay, there's something happening because if I press this and rules, it should give me the option of adding a rule to it, but it's not. Okay, I'm going to see if I can add it directly. Something not happy with my AFC deployment. Okay, I'm going to add an existing rule. Okay, cool. Okay, need to check what's happening there with the screen. Might be a GUI issue. Right, so ping is now working. Okay, this is now changed to allow. So the question would be, can I do anything else here as well? So I can't SSH to that remote host because I'm now hitting the default deny again. So I've allowed ICMP, I haven't allowed SSH. So if I want to fix that, I can also come into PSM and I can do things from here as well. So I can come to security policies. Here's my production DB network policy I just made. Here's my ICMP rule. Beneath this, there is an implicit deny. I'm going to add a new policy here. Right, we're going to permit this traffic. We're going to, why is it not letting me do this one? Need to change the source destination. We're going to be 192.168. We're going to get very specific here and go 120.11, 12, save. So this is now allowing traffic from 11 to 12 SSH. We have to save the policy in PSM. It's a bit different from AFC. Right, that now works. Cool, now on B2. It can B2 SSH back the other way. It can't because the policy only allows traffic from 120.11 to 120.12, so not the reverse direction. Rightio, and we have an implicit deny, so nothing else will work between these two. So what I would do for a production deployment is probably add a rule at the bottom to allow everything, and just put in here any, that, and do that, or potentially even just open it right up if you want to. Need to add a 0. Cool, I'll probably put an allow all here just to ensure that we get this, make sure there's no matches against this. Right, that now works because we'll now hit this catch all at the bottom. Right, so we can move things around here if we want to as well. We can move this up, we can move this one down if we want to, like that. If we want to reorder policies, so best match will be first. And let's see if it's been reflected inside here as well. Now, there's definitely something wrong. Here we go. I think it just wanted some rules in there. I don't normally create them without rules. So SSH, ICMP is in here. Right. Now I can also come in here and change my, let's do my ping again here. Okay. If I want to stop my ping, I can actually just select this, drop, this tick box here. Right. So what I did there was, I've come into PSM. The policy was created inside PSM, but I've come to AFC. AFC knows these policies. It gets pushed back this direction. I can change the policy, then pushes it to PSM. PSM pushes it to the DPU. Right. Any existing session table entries that exist will be re-evaluated and changed. So we now have this as a D. I can come in here and change this back to whatever I want. A little bit too quick. It's not good using ICMP for a demo actually because of the very nature of ICMP. Something has happened here with this. I'm going to refresh this screen. No, I didn't change that properly. Drop, allow, tick. There's nothing being pushed to PSM properly. So this is interesting. We need to have a closer look at this. Don't think my AFC is happy. Okay, see if PSM has picked that up. I'm going to start a new ping. Right, this is a stale ICMP entry, I think, because ICMP, we have to hit the default timers to time out, which I think is 3 minutes. The global timers are configured inside idle profiles. So we would have had to wait 60 seconds for an idle timeout because ICMP, yeah, the way ICMP works. Right, okay, that's good. It wasn't something strange happening, it's just the protocol. Right, so we can run through that again if we need to, but really we create our PVLANs here, our layer 2 constructs, push them into AFC, it provisions vCenter, it provisions the VLAN into the CX operating system, it maps the points between these two locations and configures the relevant trunk ports in here and here, and then we get to attach workloads to the isolated VLAN instance. Proxy ARP steers traffic up here. Redirection forces traffic to the DPU. Policy and rules control the traffic between any two IP addresses or subnets that are configured. Now, if we have multiple VLANs inside the network as well, we need to be aware that if I have multiple VLANs configured, so right now my work was between, I had VLAN 1200, which I've redirected. And I'm going to go to VLAN 1300. That includes the isolated instances in there as well, which is not redirected. So if I was to draw this out, and I have my CX10,000 switch here. Now this behavior would be the same for any sort of firewall. If I do a TCP connection, the first thing I do is a TCP SYN to the destination. Right, so that SYN packet will turn up on the switch. It's been told to redirect VLAN 1200, so that gets pushed up to the DPU. DPU has now got a session table entry. Current status or state is SYN, so it expects to see a TCP SYN ACK, so the packet gets sent back because we're just a bump in the wire. We send it back to the end user, which is on a different VLAN. So we've routed through SVI. So we're going to SVI for 1200, SVI for 1300. So we've gone from here to here. Coming back, we haven't redirected VLAN 1200, so the packet, the SYN ACK, comes back here and gets sent to the remote destination. It doesn't get sent to the DPU. Now we do an ACK, right? So we come back with an ACK here. We have to redirect this, so this is an ACK. Comes up to the DPU. DPU goes, hang on, I've seen a SYN. I'm expecting a SYN ACK, but you've just sent back a ACK. So this is not. So there's a big fat no. So communications will not be sent on here. We're not going to send anything here because the state of the TCP three-way handshake is that we need to see a SYN, ACK, ACK. Likewise, we need to see SYNs, ACK for the communication flow to continue until we see a TCP FIN packet. Then we tear down the session. So make sure we have all our SVIs configured, or even still, if we're routing somewhere else, if our gateway is somewhere else over here, we still need to have redirection configured so we can still see this behavior. Otherwise, we are breaking TCP. Also, the native VLAN, we need to potentially redirect that as well. If we have things like PSM or AFC or vCenter sitting inside a different VLAN, and we need to route between them through exactly like we're doing here. So keep that in mind. So I think we have covered pretty much everything here. We've got network creation, multiple network creations, layer 2, layer 3 configurations, the different moving parts here. Once you've done this once or twice, it'll be pretty common sense what's actually taking place. And then traffic is forwarded, we log, we create policy. So first thing we did was redirection. Then we did policy. We did a policy with no rules, which means you hit the default deny, right? Which is not good. We still log though. We then added a policy with rules. And when we do this, I would always add a allow any rule at the bottom. That way we have our matches here. We capture everything at the bottom, and when we're happy that we've got our rules correct and we no longer see any policy matches here, we can delete this. All right. So use this type of approach. Stateless. Basic switching and routing. Redirection. Policy with rules. Policy with rules and an implicit allow all. Then eventually we look to remove this once we're happy. Attach your policies potentially at the VRF level, not the network level. So if we have a VRF, let's say it's the default VRF, and we have multiple networks attached to it, so VLAN 1200, 1300, 1400, and we have our policies here, then each of these interfaces will follow this policy. We can also have policies attached here, as well as these ones. We'll do these ones first, then we'll do these ones, and these are all egress policies. So egress, I would probably just start out with a policy attached to the VRF, and then we know what is allowed to communicate to each other inside that default VRF. Okay, hopefully this makes sense. If you've got any questions, please let me know, and here to help. Thank you.